With that, we'll go ahead and get started with some tips and tricks that I have. So, the number one advice that I have for teams in all rounds is to have what I call a NOPE, a no penalty expert, who really is someone whose primary responsibility is to make sure that you don't get any penalties. Because penalties are the thing that will keep your team from going into future or from qualifying for the semifinals. And the reason for that is that there's a lot of people that get 0 points or get negative 100 points because of the amount of penalties. And there are some rounds in the past that it actually wasn't a lot of people that even got any points at all. I think the most extreme in the last few years was I think about 20 teams actually got any positive points, and everyone else got 0 points because of the amount of negative points that happened. So this person, this Nope, is someone that's calm and level-headed. A lot of times, the teams will have someone who has hands on keyboard and is scrambling and is that innovative person or that technical person who's messing with SDK and doing a lot of things. And you don't want that person to be the Nope. You want someone that's calm and level-headed, who's kind of off to the side, who doesn't get really wrapped up in the excitement of it. And that person is responsible to make sure that you don't get any points off. And I've seen in the past that in the last 10 minutes before you submit a solution, someone gets this great idea and they try to change everything about their solution. And that ends up just because they think that they can get an extra point out of a better solution. And that ends up getting them 0 points because they get so many negative points. So this Nope person has veto authority. They can say Nope to anyone else that is trying to do something or scramble or has a mad rush because they think that they have a better solution if the Nope feels that what they are doing might result in penalties. So that Nope would have a good understanding of the penalty paper, which this is the first time the Seller Explorer's staff has provided this. So that this is basically a checklist that you can go off of and get an understanding of, are we doing any of these things that will get us negative points? And then specifically for QR1, there's other things as well. There's having SDK parameters that people have messed with. One of the things that I recommend for that, if you have time, I always recommend that you go off of the original VDF that was before you edited everything, and you change just the parameters and you submit that. So over the course of 5 hours, you all are trying to do different things. You're doing access reports. In that time, I've seen that that a team might have accidentally messed with something that is a parameter that they shouldn't mess with. And so their solution that they submit has something that is wrong about it. You can solve that or have that be less likely by right before you submit, reopening that original VDF, changing just the parameters that you know you can change, the classical orbital elements, and then saving and then submitting that essentially clean submission. Other things for QR1 is your orbital parameters are out of bounds, anything in the penalty paper, or anything specific when you actually open up QR1. So as you start to go into QR1, that Nope is going through and making sure that they understand everything that it says can get negative points. In terms of what matters more in terms of the orbital elements, what I usually recommend for people is that you are primarily looking at perigee, apogee, inclination initially, and you are focusing more on that, and then you start to go into write essentially ascending node, an argument of perigee, and then finally true anomaly, which true anomaly really matters the least amount. But with those first few, that allows you to get a better understanding of what the relevant values are that you need to change. But then you can always go through and continue to edit and adjust. And I'll talk about that a little bit more in a little bit. So one thing that I highly recommend for people is that you do not get a false sense of confidence. And I've seen that a lot from people that they have gone to PR1 and they've got a good score. And so they feel like they have everything they need to go into QR1. I feel like this is one of the things that the way that the competition is set up has the biggest limitation and the biggest impact towards new teams because they really don't know what they're going into. So the example that I give is that the sample scenario that you find online is first grade algebra of 2 plus 2 equals 4. PR1 is where you get into a little bit harder, a little bit more difficult, but still not too bad. You're doing multiplication. And that's where you all are at right now of just going through PR1. When you get to QR1, if you're thinking that it's going to be that exact same difficulty, that's where you've been led incorrectly. And really, it's calculus level when you get there, and you're doing things that you've never done before. You have nothing to prepare you for that, or that you even know you need to have that level of understanding in the problem. Common mistakes that I've seen for QR1 or for PR1. The first is writing everything down at the start. I've seen teams come up with this big spreadsheet where you have a lot of information on every single solution you put down, and you say, okay, I'm going to try inclination at this and argument of parity at this. And they're literally writing down every single value for every single thing that they iterate on. What I actually recommend is that for the first hour or so that you're solving and you're in STK, you don't actually write down anything at all. You're just getting an understanding of what is something that gets good points, what are the things that increase your accesses, what are the values that seem right to you, without really having to worry about writing things down at all. For those that saw my examples run through of PR1, I solved that, I think, in about 25-ish minutes, or not solved it, but I got to a good solution within 1 point of the top score in about 25 minutes. And I did that without ever writing anything down because I was just focusing on what was increasing the accesses that I knew were relevant. All right, going on. So common mistake number 2 is making too small of changes too quickly. So what this shows is, and this is basically, I think, some sort of from some math paper or something about how to solve for and avoid local minimum or maximum. And what it's showing is that you're making big changes initially, and really you're just trying to get an understanding of what that rough layout is of whatever you're trying to solve. And once you get a good understanding of where the valleys and peaks are, then you start to do smaller iterations and go smaller and smaller to get an understanding of what needs to happen. And so that's a mistake that I've seen as well on teams, is that they're quickly starting to go down to the decimal places, and they're making changes to inclination of 35.001, and they're seeing that that's making a difference on the points, so they feel like they're getting better and getting closer, but really that's going to hurt them. So I would recommend that you don't ever do decimals until the last hour of the competition. That if you think you found the best solution, then try something completely different. Change the numbers to other values and see if you can find something that's actually better than that. And I think this is what this shows, is that in all the possible solutions, you really want to try to find the area that has the most amount of points, and you don't want to spend a whole lot of time over here, but that's what I've seen teams start to do. But in reality, it's even more complicated. This shows a two-dimensional plot of basically an X and Y, and then shows this is a topographical map, so it shows the altitude or height of different mountains. So I've seen teams that in this example will see that this is a peak, an area of high altitude, and they spend a whole lot of time trying to figure out what is the exact center of this that gets a good amount of points, and they completely ignore and don't understand that there are things over here. So what I would recommend is, as someone is going through SDK and solving and putting in a bunch of numbers, there's someone else that has a whiteboard or a piece of paper, and they have all the different classical orbital elements written out, and they are giving a little indication on what things give a higher value or a higher point value or more points associated of, okay, inclination, it seems like the higher we go in inclination, the better that is. For apogee, it seems like the higher apogee we go, that's better. And you can get an understanding of, for each of these 6 different variables, what are the things that are, what are the numbers that are most beneficial across those. And again, it could be complicated. This is a two-dimensional plot. In reality, it's 6 different variables, so it's 4 additional basically dimensions that you have to be working with. Common mistake number 3 is not knowing how to refresh access reports. I'll show that a little bit, and then I'll also post a video. That's from Stellar Sanchez that shows that. I've seen people waste hours because they're closing access reports, going back to access reports, running a new access report, and they don't understand that there's just a refresh button that they can hit. Okay, so I'll actually go through and walk through that right now. I'm going to use one of my sample scenarios to walk through that. Um, so essentially, what I do when I first open up and get everything set up is I set up the access reports that matter the most. And honestly, I don't remember in this scenario what the right things are. So forgive me if I do these accesses wrong, but I'm just doing this as an example. Let's say this. Let's say the antennas are going to the places. So when I set that up, once I've now set up this access and assuming this access is correct, I never have to do that access report again. I just have to hit this refresh button up here, and that is automatically recomputing everything about that access report. So I can quickly go and I can go to my monitor sat. I can edit the properties. So I can say I want an inclination of, not 710, of 70. And I can run it again and I can see whether that works. And I can continue to iterate on numbers, and I can do that very quickly without necessarily having to write everything down. And I can just be looking and seeing whether the accesses are increasing, whether the numbers are increasing. All right. Common mistake number 4 is not trying to think logically of an answer. So usually what I would recommend for QR1 is that you have a team that's actually in SDK trying to get a good answer, but you have another team that isn't in SDK and is just trying to think through what the correct answer is. So I have some examples here of, let's say you're trying to do something and take pictures of the North Pole. Someone doesn't have to necessarily go into SDK if they have an understanding of what the classical orbital elements are, and they would know that if you're only trying to take pictures of the North Pole, then a highly elliptical orbit is probably what you want to do. So you want to have your apogee high, your perigee low, and then you want to have an inclination of 90 degrees so that you're going directly over the poles, and an argument of perigee that's at 270 so that your apogee is over the North Pole. So that's now 4 of the 6 classical orbital elements that you can have a good understanding of even before you open up SDK. Another example is if you're doing things that are mostly concentrated in the southern hemisphere, you again probably want low perigee, high apogee, argument of perigee at 90 degrees so that now your apogee is over the southern hemisphere, and an inclination that's roughly 5-ish degrees above the most northern or southernmost point. Again, this is just an example of maybe something that would be a good starting point, not necessarily the exact perfect answer. And then if you need to take pictures of things spread across the entire world, then your apogee and perigee probably want to be as high as possible so that you're spending time across everything at the same time. So these are just examples, not necessarily perfect examples, but really trying to make sure that the point is across, that you should be trying to think of what is the right answer from a logical perspective. And a lot of times that can help you out a lot as you try to understand what is in the trade space. Okay, I think that is the end of my PowerPoint. I think what I'll do is give it up for if there's any questions or any other advice. I know there's a few other mentors that have done previous years as well. So any other advice that any of the mentors have, or questions that anyone has. And while people are typing out, the other thing that I recommend, and I'll post this in the page as well. The sample scenarios that I've come up with is what I believe is more representative of the difficulty of QR1. So especially for a new team, I would recommend that over the next 2 weeks, you try to actually go through and solve this. And I think what you'll find is that the difficulty is much greater than you have found with PR1. Usually there's more satellites, there's more components on each of the satellites, there's more options that you can select, there's a lot more places that you need to do access reports. All right, so question of going from a team of 2 to a team of 5 this year. and tips on having the entire team member or the entire team engaged. So um, that's definitely a valid concern, and I think mostly for QR1 more than the other ones. For the other ones, I think it's a lot easier to break it up into different different jobs or tasks that each team member can do. But I would say for QR1, um, definitely encouraging the teams to take a fair amount of time actually going through the quiz. That is something that can occupy a fair amount of time if you're not just having people give the answer that they think is right, but actually have for every single question in the quiz that I'm going to go into the resources and I'm going to find something that word for word gives this answer is something that one ensures that you get 100% of the points for the quiz and take some time. The other thing that I would say is that kind of what I mentioned of having a team that is doing STK and then a team that is logically thinking through the solution makes sense or is a way of breaking it up and having it be where the team that's on the whiteboard says, well, we think that your inclination should be fairly high for this, and the person that's doing STK has that same thing. In terms of actually running the computer, I would say that the maximum for that is really about three people. And that's probably the person running SDK, the person next to them that is writing answers or numbers that seem to be pretty high, and then the nope that's always there and is always making sure that there's nothing that is being done incorrectly. And so that's a way to split it up and have different responsibilities. You have two people that are quiz experts or quiz leads, and they're also maybe doing things on the whiteboard to try to think through the solution. Having someone who's running SDK, someone who's writing down good answers, and then having someone that's being the note. And then yeah, I think a good suggestion as well here of rotating people, giving and testing ideas, especially because if you're really using the entire 6 hours, that is a long amount of time, and you really want to make sure that you're not getting into that local minimum area where you think it's a good answer, but it's really not. So that's why it is good to maybe have someone else switch out and sit down at the computer and give a completely different numbers that you start off with. The other thing that I would say with that could potentially be good, do it blind with the different team members. So have the people that are doing the quiz not give what their answers are to the quiz, but write down on a piece of paper that the other, so I'll say group A and group B. So group A is looking through SDK while group B is doing the quiz. And group B writes down their answers on a piece of paper that group A can't see at all. When they switch off by resetting STK. So when group B starts doing STK, they don't know at all what group A was doing in STK, and now group A is doing the quiz without any understanding of what group B was doing. And at the end, they can compare the answers of what they came up with. And if all of the quiz answers are exactly the same and they're confident because they went and they looked in the resources, that's probably a good it probably means that they're going to get a pretty good score on the quiz. And same for STK. If they independently come up with answers that are vastly different, that's an indication that someone missed something and you should compare and get an understanding of which one is actually better. All right. I think you're able to speak.
Hi, can you hear me?
Yes.
Okay. Uh, Thank you. So my team is fairly new to the competition, and so am I. We were going through the PR1, and we didn't really know like, how we should go about thinking for the values for like RAN and true anomaly and argument of parity.
Okay. Yeah, so I talked about that a little bit in terms of some examples, but that is definitely something that for a new team is a problem that they really treat all of those variables as something that is uh, just random variables to edit and mess with the numbers. What I'll do, let me see, I'll show with here. So uh, in general, and let me, can I hide this? Yeah, I'll hide that. I'll hide those things, so I'll make it a little bit easier. So if your team doesn't have that kind of foundational understanding of what each of these things changes and why they're good or bad, I would definitely say to look at it a little bit more. I think Nova Space has some good material that kind of walks through it. I also think that there's some good information from some other mentors that kind of walk through uh, ways to have it, ways to understand it a little bit more. But in general, if you're doing perigee or apogee, what that's really doing is that's having you go further up or lower down in terms of where you're at. So I'll use this as a crazy example. So if I do this, I've changed my apogee, and so now I'm spending a lot of time, and you can actually see that. I'll make this bigger so it's easier for you all to see. So you can see that when I click play, is that the satellite? Where's the satellite? Oh no, why is the satellite not there? Where's my satellite? Well, that's a bad example. Let me just insert a new satellite. Hold on. All right. Is that satellite visible now? Oh no. All right, bad examples. All right, so then I won't show it in SDK. But so changing your apogee and perigee is really what is allowing you to have an understanding of where you want to spend more time or the distance that you want to be from objects. And so a lot of times, if you are trying to spend time directly focusing on a specific region of the Earth, that is where usually you want to have as low a perigee as possible, as high of an apogee as possible. And then that is closely tied with the inclination. So in this example, if I want to have my inclination at 0, really an inclination of 0 is only beneficial or only useful if you are wanting to do something over the poles. But, oh, this is basic orbit 1, never mind, here. So only if you want to do something over, not the poles, over the equator. So in this example, I have an inclination of 0, and so I'm spending all of my time over there. What I usually give as an advice is you want to have your inclination at, you want to start it at roughly 5 degrees above or below the area that you want to be looking at the most. So in this example, if I look at what place 1 is in terms of its location, its latitude is at 58. And so if that was the only thing that I was looking at, I would probably start initially with having the inclination be at roughly 62, roughly 5 degrees above. And you can see that actually with here of these are the places that I want to be looking at, and the inclination is not going too far above that. So that's one example. And then argument of perigee is really where you want to be spending a lot of time. In this example, it's 180. If you do 90, you are now spending a lot more time over the southern regions. And you can see that based on the length of time that the orbit will be taking down at the bottom. Does this show? Oh, there we go. Okay. Let me see if this starts to show it. Okay. It shows it on the 2D plot, so I'll do that. So you can see on the 2D plot with this, and I'll slow it down. So it's spending more time down here, and then it kind of zooms quickly through here because I've set up that argument of perigee here. So this orbit would be an example of something that would be good for southern locations. In this scenario, what I have, it's actually the opposite of that. So you would want to have the argument of perigee at about 270. And then finally for RAN, RAN is really only relevant if you are trying to change or twist your orbit to be over a specific area. So if I stop this and I change the RAN, what you can see is that the RAN, all it does is changes the direction. So I'll do a smaller change, a 55. It twists it relative to where you are on the Earth. So again, I'll do a little change. I'll do 65, and you can see that little twist. So that is relevant if you're trying to line something up to be perfect where you need to be. And then true anomaly is the least important thing, and that is really just setting your initial conditions of where you're starting in your orbit. But again, that doesn't matter too much. So what I would recommend is really these first 4 are the things to focus on, usually initially getting your apogee, perigee, and inclination. Then start to think about your argument of perigee. then just start to think about your RAN and then go to true anomaly after that. Again, that's kind of a little bit quick. I would say there's some other videos that are a little bit more thought through if you are trying to get a better understanding of it.
Yeah, thank you very much, sir. I appreciate it.
All right. So I'll go ahead and post this video as well so that you can look through it in more detail. And then if you have any other questions, you can feel free to post it in the channels. But good luck going into QR1. I will say, again, like I said at the beginning, if you think that you did well at PR1 and therefore QR1 will be easy, that is something that a lot of teams have fallen into. I definitely think that there are some things that as a team you should be doing. One of the things is doing the practice scenario that is more representative of the difficulty of QR1. With that, we'll end this. So thanks so much, everyone.